The diagram shows part of the graph of y equals 2 cos x minus pi by 6. The graph intersects the y-axis at the point A, has a maximum point at B, and intersects the x-axis at the point C. We want the coordinates of A, and A is the point where x is equal to 0. So we have y equals 2 cos negative pi by 6. Now you have a calculator, but this is a standard angle. The cosine of pi by 6 is root 3 over 2, and the cosine of negative pi by 6 is the same as the cosine of pi by 6 because it's down here in the C quadrant. So we have 2 times root 3 over 2, which is root 3. So A is the point 0, root 3. Now, we want to find the coordinates of B, and we can see B is this maximum point here, but we don't need to differentiate to find that. I mean, you could do if you had to. We know that the standard cosine has its maximum value here when x equals 0. But here we've got x minus pi by 6, so we need the angle in here to be 0, and that would happen when x equals pi by 6. So if x is pi by 6, we've got 2 times the cosine of 0. The cosine of 0 is 1. Again, a standard value you ought to know, but you've got your calculator if you don't. And that means that y is equal to 2. And therefore B is the point pi by 6, 2. Okay, moving on. So part 3 is down here. Find the coordinates of C, and that's where we cross the x-axis just here. So again, if we think about the standard curve, this 0 happens at pi by 2. So we need x minus pi by 6, that's the angle inside the function. We need that to be equal to pi by 2. So x take away pi by 6 needs to be equal to pi by 2. So x is going to be pi by 2 add pi by 6, and that's 3 pi by 6 add pi by 6, which is 4 pi by 6, which cancels down to 2 pi by 3. So we have that C is 2 pi by 3, 0. So now we want to find the integral of 2 cos x minus pi by 6. Well, cos integrates to sine, so it's just going to be 2 sine x take away pi by 6 plus a constant. Of course, we would need to apply a sort of reverse chain thing, but the differential of the inside is just 1 anyway, so it would just be what I've written down here. And hence find the area of the shaded region. So let's just go back and look at the shaded region. Well, we know that goes from 0, and we found that this is at 2 pi by 3. So what we would want for that shaded region is the integral from 0 to 2 pi by 3 of 2 cos x take away pi by 6 dx. So we've just done that integral, so we know that's 2 sine x take away pi by 6. We don't need the plus c for a definite integral, so 0 to 2 pi by 3. So that's going to be 2 sine 2 pi by 3 take away pi by 6 is pi by 2. Take away 2 sine, put 0 and we get negative pi by 6. Sine of pi by 2 is 1, so that's going to be 2. Now sine of pi by 6 is a half, but we're in the C quadrant here, so it's going to be negative a half. So we're going to have 2 take away 2 times negative a half, which of course is negative 1. So that's 2 take away negative 1, giving us 3 square units.